Okay. So here's something I came across. I've developed a fake account before on a platform like Facebook or Instagram when it was came out. I knew the developer making some apps, and this is years before it came out, basically. Even though it was sold to a different company, I had accounts that were illicit. In the words of another system administrator, illicit, but they were legal by the foundation of creating them. They were fine to create and use. So basically, I made the account. And I don't have them. I don't have access to any of these accounts anymore. They're either deleted or somewhere on a hard drive somewhere. So basically, the one thing I noticed about the accounts is they all are arbitrary. So they all have unique keys, and they all could be inputted into a user setting like Norton security system, like privacy protection or identity protection. For theft, you can input your username or face recognition into the protocol, but it looks like Norton doesn't allow me to record through this. So, one way around was when I was younger. I mean, this was implemented in probably version 2 of the beta, right, or probably before that, probably alpha. It has to do with getting the application code and recording this information. So you have to get a virtual system to do this, all of it. So I can tell you, there are some arbitrary keys out there that are unique for opening up, a system like this, and they will still do it on the same system, same jurisdiction, everything. Yeah, they will. They'll follow the same rules. It's like outplaying the system and like programming and database management, AI, same thing. When you do that, the system, automatically updates and, the block basically. So it's a good question of like how to, fumble into these keys. A user programmer, someone hired for the company, isn't just hired. They have to develop all the keys identical to getting hired, basically. They have to orchestrate that. And from what you can see in the system, like, looking around, from like, array tree to array tree or, anything else, blueprint, you can see it all is disarrayed. There's this like organic and inorganic structures in the programming or, profiles. They look illicit. It's the same thing that happened, when the programming code was introduced to do this. It was a JavaScript Swift language, and it focused on arrays. It was to check the system, basically. I was against it from the start. Basically, it was introduced and it caused a script error with Apple and JavaScript. So that's one protocol that was orchestrated and manifested a problem over time. So, it's a good question. So, you upload like a username into a program like Norton Security. Will it build the script? Is it using Swift and JavaScript? That's the only way, like, to simply solve the problem is to use the same system, right? The same system that the programming code is on. So if it's like, Apple, it would be Unix or Swift and arrays, but it's not that simple again. So you could tactically, fundamentally do that, right? You have to have your sets of arrays just correct. They have to be all correct, basically, based on your block. So it's another question of arrays versus like development. That's basically when you're safeguarding all of the information on the block, right? You're determining the array, the function. So when you determine the function, the calculation of the array, and you put the input in, which is the function like equaling something, right? Or what does the function do, basically? You take that function and you derive a dividend. So that dividend is an inequality in functions and arrays. That's a definition of the function. The function basically acts as a system array covariance, which means It propagates the shell, it has an open container, and it shows you the tree, array, and database. So with that information, you basically set the parameter, and that'd be like a programming language. That'd be like Swift, or like Focus, or Scratch, or anything protocol-wise. Any JavaScript language at all, or any database language. But databases are a separate conjunction from arrays. So don't get it wrong. Arrays, do work with C programming language. They work with C#. They work with C++ technically, and I always say technically because people get this wrong all the time. C++ doesn't just work on C++. It has arrays from different intelligent systems working for one focus. They call it C++ because it's built from PHP, JavaScript. There's a few languages that go together and builds, the focused intelligence behind those arrays and variances. But the further deep you go into, arrays of variances and technology, you learn that the system is a dynamic of something called a protocol network. A protocol network basically sends signals to different functions within the shell. And then more as you grammatically go into language development and programming, you learn that is what holds language together. So all the arrays, containers, shells, all of the functions or basic code, they go into what is like a script square, basically. It's one calculation, one unit, or one protocol per variance. And that variance basically determines what input and output comes from a language. That language basically takes that output and array, right? That ovariance, that array that goes in between, two functions, right? It sets the weight as a dynameter. So that's the container basically. And it sets that dynameter as a protocol between two shells of two containers that are connected through two protocols. Those two protocols are basically like magnets sticking onto each other. Those magnets go onto each other and they basically focus the purpose. So they drive one way or the other. That's basically like one line connecting to the same line that's going around in a circle basically. So what that does is basically protects the shell or script container of the language once again into another shell. That shell basically sends a signal that it's a step. It basically amplifies the signal ups the computing, and basically, it aligns the communication. So it can tell you dynameter, it can tell you scripting language, it can tell you protocol. And it's like an array. It's like you go back to these basic programming languages like BASIC and Microsoft, you'll learn it's the same kind of principle. Visual Basic is, it has sets, arrays, and more arrays. And it is frustrating because it does have a long list of arrays you have to focus on, and the calculations, they're not dynamical. They don't fit into databasing quality well, but the system really has been updated because you look at C language. It's based on those arrays and functions and shells that connect together at the magnets. But does it list? Does it draw on? Was it before the World Wide Web was at its best? No, it wasn't. It was at quality, control, coerce, and communication. So those were the big 4 C's, but there was only 3 C's involved. Communications wasn't really developed until communications went on an outward path or footwork towards more development. JavaScript, for example. That's when communication became more invested in administration and schooling. That's when education was more dynamic, more databases grew, and that's when the necessary need for that branch or technology or that array tree came about. So the more you go on, the more you could find out more information about arrays and technology, right? Or functions and variance and output. But the protocol, going back to the protocol works as a shell script that basically tells the server or the system to have 2 outputs. Those 2 outputs are variance and function. Those work as array, and the other missing unknown output is the solution. So the solution basically works with 2 outward paths. Those paths work on dynamic and dynameter. Those protocols work on two central systems, each with the same dynameter and dynamic, but they work on two central, what you might consider image and outputs. That's like kind of a CPU or RAM. They both use those like quality and control to populate data within a central system and overflow it. So what an overflow is basically, it's a manual way to take the system, the output, and clock it. So that basically means you take all the information and you drag it, in a container all the way to somewhere else. That basically tells you what is right and what is wrong, like a true or false kind of methodology. It basically sticks a log onto whatever object, you're putting on, and it doesn't really do anything. It just pushes it slightly. It's like an array again, but this time it's three-dimensional. Like the variance, the output, the array itself, they're all, now like they're dying basically. Like they don't do anything. They're just set functions, principles, arrays that are imprints basically. What those imprints do are, basically they input information into, again, two different systems, which is, how, the language, starts to orient itself into, the consumer product line or, the maintenance, what you might consider the latency. And that goes on to a lot of different principles like LCX or, different administration tools or logistics, basically. So basically, like JavaScript is one language output that has two developments. A lot of people get it wrong, where there's again two developments, more than two developments, like C++, right? And it goes on to the scripting languages that develop these languages, before C++, the firmware basically. So what you get in principle is like a giant magnet, like dragging information. That information takes the path, copies it, selects the control, it deepens or depends the system on certain protocol or imaging quality, which means it pinpoints the exact location of what it's supposed to do. Basically, that's an array of, a mean. So a mean is basically a curved signature, basically, and it tells you out of all the data blocks, which are not squares, but like, as square as they can be. And they tell you, what selection did you make? And the selection is square, right? Because the square is like a signifier. It basically signifies, the principal code of what the principle is. Like what selection is basically, your plot. It doesn't really look square, but it looks like a technical signature. So that signature basically sticks around and it consumes the data. So that data is consumed, sends a signature into the next collateral, the protocol. It basically tells your system that it's waking up, slowing down, or it's a composite. So that basically means it's running something like a certain signal that would colorize brightening. It would brighten. So like when you take a magnet and you stick it to a window, it doesn't do anything. But the phosphate or the sand that has metallic material will absorb it. It's kind of like an array function. It's how a signal would work with like an isolator that's stereo. So basically, it works with the same technology as like a video processor in principle, and it sticks an array, takes the input and output, and then magnetizes the signal. So it's a good question, like how the information ends up on your screen. So you take the circle, the half circle, or the magnet. Basically, it's not like a magnet. It's not made of metal. It's made of like almost glass, plastic, right? Because the computer is made out of metal, right? It's plastic, metal, whatever. It's glass, like fine mineral in the computing chips. You take the information. You see, what you have, the array, the tree. Those are visual, right? Those are things that can be imprinted on the circuit itself. Those things, harbor like user information, IP addresses, technical information, like technical graphics or information about systems or technology inputs, outputs, arrays, dissymedias, vowel inputs, distortion, fact or fiction in one way, which are like inputs or stereo, isomers or outputs. So those are basically like, what is like joy from wrong in the system. Those are like overflows. That's what an overflow valve does. It's the flash technology in the computer. And that's like the way a circuit in a flash bulb would work, which works with water dynamics, mineral dynamics, things that count in, manufacture, like, chemicals, release signals, all those things. So you take those circuits, you can hook them up to each other. That'd be called like a child, basically. A child, like, system administration toolkit, right? A lot of people don't call it that way. It falls off the road there in a while. You don't really know what to do with it. A lot of people don't talk about it. It's more of a administration etiquette, really. That's what you plug in your system. But you look at the technical, like, graphics, for example, those, run through the system. And they get pulled, right? Because that's what the system does, the magnet. Basically, it's clocking everything. It's going one step, and that's making it go two step, and so on, until it reaches a certain verdict in the system or protocol limit, right? It's not called a protocol limit because it can go as much as it can. The computer can crash, but the object of the game is to make the computer go by one signal at a time. Count each application by one signal, but count it the right way. So how do you do that? You count it by electricity. You count it by signal variance, outputs, control, and, of course, methodology. The system, server, stays onto the circuit board. The imprint works on the quality control check, which is like the RAM, basically. The CPU has it too, but the CPU can, like, dig a pool, basically. The pool basically sticks the variance array, stacks the overflow. So that's where, the input-output arises. That's where the 3D dimension of the CPU or the circuit, breaker, in a way, the output variance control methodology, come together, and they basically stack to each other. The flow is the output, and that's, how the stack occurs. That's how the file arrives its data pool, its version. So basically, every number is stacked into a different protocol. It's an algorithm. It's a cryptology, meaning. So basically, the stacks, become greater, wider, and the squares aren't any square anymore. They're more rectangular. They follow a direct path. They get faster. They get steeper. The dragging force, goes up higher. The price of electricity or the cost of electricity or the value of electricity goes up even more. The technical, skill of the server, comes out to, like, stop viruses. What are viruses? Those are like the clumsy little things that, stick to your side of your server. So those are like pools of information that graphically overflow the system, basically, in a, like what you consider like a body text like protocol. And that's, some of how HTTPS arrived. That's how pools and stacks no longer overflow the system and outclock, things like RAM or, different protocols. So this is 1C01. And I'll just tell you right now that, there's good protocol, bad protocol. Get your protocol right. So then take the protocol, rearrange it, and do what you mean.